Practice problem solutions. Remember, if you enjoy this channel, give us a like and subscribe. So, we have a graph which is speed and time for an object that's falling. And it says, what's the total distance the object falls? We know that the area under a velocity time graph is equal to the displacement. So all we have to do is find this area here. We have a right triangle, so we can say area is equal to 1/2 base times the height. And our base is 3 seconds, and our height is 8 meters per second. So that's going to give us an area of 12 meters, which is our distance. Number 2. A student throws a baseball vertically upward and then catches it. If it's vertically upward is considered positive, so we're taking a ball and we're throwing it like this, it's going up and coming back down, and we're defining up as positive. Then which graph best represents the relationship between velocity and time for the ball? It's a very difficult question because we have to be looking at which way is positive, then which way is negative. Because on the way up, the ball's velocity is positive, and on the way down, the ball's velocity is negative. So I just want to go over these because this is a hard question. This is showing the velocity increasing and then the velocity decreasing. But this is just an object speeding up and slowing down, but the whole time it's going forward. In this graph right here, which is the right answer, the ball is already traveling fast, which is what happens if you throw a ball upwards. The ball slows down while in the positive direction, then speeds up in the negative direction. We know that's what actually happens. The ball slows down on the way up and speeds up in the negative direction on the way down. Okay, we have a graph, velocity and time, and it says of a car, what is its acceleration at 5 seconds? So a little bit of a trick question. At 5 seconds, the car's velocity is constant, and if the velocity is constant, then the acceleration is 0. Number 4, what is the total distance traveled by the car? We know that the area under a velocity time graph is the displacement, so we have to find the area of all of this. But we can break this up into a triangle. So we can say area equals 1/2 base times the height, which is going to be 1/2 of 4 seconds times 10 meters per second. So during this portion, we have 20 meters. Then, during the second section, from 4 to 6 seconds, we have length times width, or we could do width times height, either way. Do width times height. And that is going to be 2 seconds times 10 meters per second, which is also going to be 20 meters. So the total area, which is going to be equal to the total distance traveled, is going to be 40 meters. Which graph best represents the motion of an object in equilibrium? Now, I added this note here because we haven't done the forces unit yet. When the net force is 0, that's when an object is in equilibrium. When the net force is 0, it means there's no acceleration. But there's 2 different options for the way an object could be moving. It could be stopped, or it could be moving at a constant velocity. So which of these are showing an object that's stopped? Well, none of them. Are any of these showing constant velocity? This is an increasing velocity, exponentially increasing velocity. So we know it's one of these 2. In this graph, the slope is increasing. The slope of a displacement time graph is velocity, so the velocity is increasing. So it must be this. But let's look at why. The slope of this line is constant. The slope of a displacement time graph is velocity, So this is constant velocity, so the acceleration is 0, which occurs when the net force is 0. The graph below represents the displacement of an object moving in a straight line as a function of time. What's the total distance traveled from 0 to 10 seconds? So we have to remember that distance is the total path traveled. So this object started at 0, and in some way or another it got up to 16 meters. So it traveled 16 meters, but then it traveled back to 8 meters. So it traveled an additional 8 meters. So the total distance traveled is 24 meters. Had the question asked us for displacement, that would be start to finish, and the answer would have been 8 meters. The graph below represents the velocity of an object traveling in a straight line as a function of time. Determine the magnitude of the total displacement of the object at the end of the first 6 seconds. So we're dealing with another question here where we're looking for the area, because the area of a velocity time graph is the displacement. So we need to find the area of this and the area of this triangle. So we do area is equal to 1/2 base times height, which is going to be 1/2 of 2 seconds times 10 meters per second. So that's going to be 10 meters. And then for the second one, we have, we could do width times height. So that's going to be from 2 to 6 seconds. That's going to be 4 seconds times 10 meters per second. That's going to be 40 meters. So the total displacement is going to be 50 meters. Which graph best represents the relationship between velocity of an object thrown straight up from the Earth's surface? So once again, we saw a question very similar to this. The ball goes up and then comes back down. So what does it do? It's going fast in the beginning, and it's up, so it has a positive velocity that decreases until it gets to 0, and then it increases in the negative direction. So this graph right here shows a upward large velocity that decreases, it stops, then it increases in the opposite direction. Number 9 says a car travels with a constant non-zero acceleration. Okay, so the acceleration is not 0, so that means it's accelerating. Which graph best represents the relationship between distance the car travels and the time of travel? So we're looking for something that's showing acceleration. Acceleration on a distance time graph means that the velocity has to be changing, and the velocity is changing when the slope is changing. So the only one in which that happens is 1. Which graph best represents the relationship between the acceleration of a falling object freely near the surface of the Earth and the time that it falls? So we know that if we drop an object and it's in free fall, it's going to accelerate constantly. So that means that the acceleration is not changing. Its velocity is changing, its displacement is changing, but its acceleration is constant. And in fact, we could say we know exactly what that acceleration is on Earth. It's 9.8 meters per second squared.